Hello everyone. Today we want to present you our proposal for the Biodesign Challenge Biomat. We are Team 5 and we will start by talking about the mulch. The mulch is a layer of material formed by dead matters that falls from trees and cover the soil of forests. It keeps the humidity and heat and stops the growth of dangerous weeds. By decaying, the mulch helps in filling the soil of nutrients, which in turn helps the growth of trees. This process is called bioturbation and is fundamental for maintaining life in forests and consuming less resources. For these reasons, in agricultural practice, they got inspired in using the mulching by applying a sheet of material, sometimes plastic, that maintains the same benefits. You just simply need to roll it and make holes in a specific patterns for the plants. It had a lot of pros, such as its cheap cost and easiness of applying, but also some serious letdown, like the need of discarding when the life cycle is finished, and it doesn't allow the gases from the soil to escape, as it is a non-transpirable layer, leading to poor oxygenation and a probable intoxication of the terrain. As a concept too, we have found some problems. Sheet mulching is a closed system, and as this material is not transpirable and not biodegradable, stop much of the exchange of resources that is happening in nature. A crude mimicry of a really complex system that aim only to exploit the resources. On the other hand, in nature, we see that nature breathes and behaves in a way that leads to adaptation. These have become our project vision, to make an improved and more natural sheet for mulching, thus to be reactive to the environment, permeable to gases and water, and dynamically adaptable to the place it is deployed. So we made Biomat, a parametric reactive biodegradable ground sheet for agriculture. In our design process, we have strived to maintain the biomimicry aspect of the natural mulching, also concentrated in making a feasible proposal for manufacturing, while improving in all the aspects of the existing mulch. With our experimentation, we found that an auxetic material could be the most suited, as it is stretchable material that can change from external stimuli to ease tension, like how the mulch reacts to change in humidity. In experimenting, we tested with a pattern that could react to an increase of humidity by opening. This, in a real-field application, could lead to an improved escape of gases and a rapid exchange of humidity and heat. Our prototype was made use laser cutting. This process permits to make always customable and purpose-fit design for the sheet. You can also respond to user demands, but this could also raise the price of the product. Our material of choice is a vegetable fiber felt that can be made from jute or canapa. This helps in having a material that is both hygroscopic and biodegradable, while being easy to manufacture with laser cutting. By decaying, this material will give back the nutrients to the soil. The main algorithm to generate the sheet is made use Grasshopper, a visual programming tool to making parametric structure. The parametrization of Biomat permits to have custom sheets made for different terrain and plants, with a pattern that change depending on the parameters that the user input. Such parameters could be like the space between the different plants, depending on the needed and the pattern that we're following. More space for the plant itself is needed, also without the need of making holes, and a variety of patterns to adapt to any terrain and inclination. Now we want also to discuss some possible reflection on our project. A great given of the natural mulch is the capability of this component to change shape depending on the amount of humidity and heat, helping the process in this way. In our research, we sought to obtain the same effects in combination with our auxetic structure by applying as low-tech actuators strips of veneer or hygroscopic materials that could follow predetermined paths, similarly to how pine cones open and close. We follow some papers and similar experimentation from MIT and the University of Stuttgart. We didn't bring on after experimentation because of the existing doubts of the continuous reliability of systems like this in a long-term user scenario, and also how they could be manufactured. But surely this opens to interesting future development for this project. With our project also, we aim to make a product that could improve and make it a better tool for agriculture all around the world, following a natural strategy, but at the same time we strive to achieve a product that could also permit to grow following the same principle and cycles of nature, not to fuel a cycle of only exploiting and then having to give back, but continuous one of exchanging resources and growing together. Thank you for your attention.